Hello and welcome to this demo video called Vibe Coding Securely with the Model Context Protocol. In this video, we're going to take a look at a prototype that embeds the principles of secure by design into an AI-enabled software development workflow. But before we begin the demo, we need to understand the context, no pun intended. So generative AI, large language models, and specifically agentic AI is really changing the way we think about writing software and also securing that software. There's been an explosion in the use of AI for writing software and changing software, even to the point where we have new terminology like vibe coding, which is basically the idea of the AI doing most, if not all, of writing the code, leaving the human really to think more about what's happening at the design and behavior level of the software that we're building. Historically, AI was writing some pretty buggy and vulnerable software, but there have been significant improvements in this, and I think we'll continue to see those improvements to the point where the code written by AI is going to be virtually bug-free and vulnerability-free. But what does that then mean from a security point of view? Well, it puts the emphasis on the overall design and behavior of the software. And that's where the design flaws can creep in and have a significant impact, even if the code itself is not vulnerable. Uh, Released in February by Anthropic, the Model Context Protocol allows AI agents to collaborate with each other. It provides a sort of structured channel by which AI can discover and use other agents and tools in order to achieve a particular outcome. And this makes total sense from a security perspective, because what it means is that we can use MCP to inject security processes and checks and things like that into an AI-enabled development process in order to make sure that what the developer is doing, with AI makes sense from a security point of view. And that's what we're going to be demoing today. So what we'll do is start with putting on our developer hat. So we are going to be working on a task from Jira in order to implement a simple file upload utility that can be used internally within an organization. We'll be doing this using AI. So we'll be using the Cursor IDE. Uh, and we'll be using Claude 3.7 Sonnet as the large language model within that. And this will essentially be a form of vibe coding. For the purpose of this demo, we're not even going to look at the code that it's generating. We will just let the IDE generate whatever code it feels it needs to create. As you'll see, we'll use the MCP tools that will be embedding the secure by design practices directly into this workflow. And then we'll switch over to a security dashboard web interface to see what the results are of this workflow. And this is really more from a security perspective. This is what maybe a security engineer or a compliance engineer will be doing to understand the impact of all of these developers in the organization vibe coding, but doing so securely. So we'll switch over to a security dashboard to see the consequences of our vibe coding. So with that, let's get into it. So we're going to be working in a empty repository. We're going to be building this from scratch. We just have one file in here at the moment, which is a DevOps and deployment policy, which will provide to the AI to give some context around the DevOps and deployment. We'll be able to use that as part of the sort of design review. So the first thing I'm going to do is initialize the repository. So I'm going to run a command svd init. As you can see, what this has done is it has created the MCP configuration, as well as some curse rules that will help identify when to use the different MCP tools. And we'll also upload the document and make that available to the backend. So here you can see a fairly basic Jira task for implementing a file uploading utility for HR and finance teams to upload debugs and logs and things like that and screenshots. So we're just going to copy that like that. As you can see, we are inside the Cursor IDE. Not much going on here at the moment. We've got our DevOps and deployment policy PDF. We've got the MCP configuration and the cursor rules that we created a moment ago. So I will now paste the Jira task into the window, and we can let the AI do its thing. So as you can see, before it actually goes to implement any code for our task, what it wants to do is analyze the task using one of the MCP tools that's available. So we're going to let it do that. It'll take about 30 to 50 seconds for the analysis to complete. So the MCP tool has suggested it runs a sleep command to wait for that to happen. So let's just run that. I'll fast forward this in the recording. Now that the analysis is complete, it can retrieve the security recommendations that will help to ensure that we are building this securely by design. So let's get those. And as you can see, it has generated a number of recommendations and it's given us the option to review them. What I think we'll do is we'll only implement the file type restriction. So while it's waiting for the approval, I'm just going to tell that I'm going to use Super Whisper to save me from typing. So only implement the file type restrictions security recommendation, ignore the other controls. So it's factored that in, and now it's going to continue with its building of the application. I'll probably speed this up as well. So no, not only has it implemented some controls based on the recommendations that came from a design task, the Jira task, but it now also wants to submit the code that it's actually implemented for analysis as well. Again, really focusing on from a design perspective. So we're going to let it do that. And once again, we'll wait for the analysis to complete. So it now wants to retrieve the recommendations from the code analysis. So we'll let it do that. And then, so all good. And so as a final step, what it wants to do now is send information back to the system about the controls that it implemented. Oh, little wobble there. Okay, there we go. And we're going to let it run. So that has now, to recap what's happened from a user's perspective, it has taken a Jira task, it's analyzed it from a security perspective, from a secure by design perspective, it has identified recommendations, it's implemented those recommendations, the code that it's generated has been sent back for analysis as well, and then the implementations of the security controls have been fed back to the system. So what we'll do now is we'll switch over to the security dashboard to see what it looks like when we put our security engineer hat on. And here you can see the security dashboard. So as an overview, we can see that there are 14 threats, 9 of which are high risk. We have 14 controls, of which 13 are pending, so 1 has been implemented. We have 2 changes and 1 implementation. So we can see here the changes. We've got the task, we've got the code changes that were analyzed. We can see a list of threats. We can see the controls. And probably more interestingly, we can see the implementation. So the implementations show us what control was implemented, where and how it was implemented in the code in order to sort of introduce that control and mitigate the risk. This means that from a security perspective, you have visibility into what the developers are doing, what the implications are, and what that means for security, because you can not only see the threats and the controls that are being identified, but you can also see which ones are being implemented, how they're being implemented, and which ones are not being implemented. Right, that's the end of the demo. Thank you very much for watching. I hope you enjoyed it. If you're interested in learning more, check out our website at IriusRisk.com. We also have a podcast on Spotify and other places that you can listen to, and where we discuss everything that's at the intersection of software development, AI, and cybersecurity. It's called Organic Talk on Artificial Intelligence. So check it out. Thanks and goodbye.